Hello everyone. In this video, I'm going to walk through my solution for a test task for project ML for context in AI assistant. This video is for JetBrains internship application and for mentors that are on this project. So I will start with part one of test task, and that is to create an API that will get a query, and will respond with document that is more suitable. This is more suitable for that query that was sent. So at the start of this server.py, it will initialize a search engine. So this one, and it uses already trained mini LM L6 version 2. So, and it will read documents.json, which is a really simple JSON file. And after that, it will index all documents from this JSON file. It will take between 10 and 20 seconds to initialize and to index all of it. So a web page that I will show will not load immediately. So this one. And you will get input and search button for query. I already add two numbers and multiply two numbers. I use that already, and I will use it now. So this one, and it will give the most suitable function, or in this case document, for this specific query, and it will give you score for this between this query and the document. So I will go to part two. In part two, I will explain quickly my Quest vector search engine. So in init function, it will initialize this sentence transformer. It will initialize property for usearch index, which will be used for vector storage. It will be I will also initialize documents where all documents will be stored. Also, these hyperparameters are for usearch, and I will explain them later. First function is index documents that will take documents with the strings, and it will encode them using a sentence transformers encode function. It will transform these strings into dense vectors that will contain all information like semantic information and etc. like meanings, for example, in this for these documents. Uh, After that, it will initialize usearch.index with these hyperparameters that I will explain later. The second function is search. Search is function that will take a query, which is string, and will return top k most suitable documents in documents list for this specific query. In my case, it will be k will be 10. Also in part two, I need to create matrices that I will use to evaluate my model. So these are recall, MRR, and NDCG. So these are functions, these are matrices that I will use, and I will create the evaluate function that will take model that will take queries, documents, relevant documents, number of top k number of documents that will be retrieved, and it will call all these functions. It will call search function from my model, and it will return a dictionary with all these values of these matrices. So in demonstration in the Jupyter notebook, I evaluated this model pre fine tuning for only test part of the CoSQA dataset, and it will show these values from recall, MRR, and NDCG. I also tried on train part of CoSQA dataset, and it showed much lower numbers. I assume that because of that functions in train are much more complex, and I assume this model that I use is not trained on code. It's using natural language, and that are test and all functions in test dataset are much more simpler. And also I tried um, to get 500 queries and functions from train dataset, and it showed much higher matrices. I did that in my Google Colab because I experimented with different epochs, because I trained only on one epoch and a huge batch size of 32. Because I have integrated GPU, not external, and Colab offers T4 GPU that is much faster for computation. So I trained the model using train function. It takes so it will call prepare data that will download queries and corpus of CoSQL dataset. It will split them, and it will return array of input examples. These are wrappers from sentence transformers that will contain pairs of queries and corpuses, or in this case functions. And I will call data loader to this dataset transform into batches. And also for loss function, I will use multiple negative ranking loss. The reason I use this loss function is because this problem is a ranking problem, and multiple negative ranking loss is good for these kinds of problems, because in search engines you want the queries and documents to be in embedding space really close, and others documents are really far, that are not relevant or not suited for that query, and that multiple negative ranking loss can offer. After that, I use model.fit, that is from sentence transformer, to fine tune this model. And my last function is for plotting training for plotting loss values in training step. I code it. It took 40 minutes, and that's why I used Google Colab. It's not the most nice code, but it's in this Google Code, but I will also share it just to show you different batch sizes, how different loss curve can happen. For example, this can show that the loss curve, if batch size is higher, it's much clearer loss than on 32. So after that, I evaluated again on the test, and it didn't show much improvements on this because it was already high, but on these two matrices it shows very solid improvement. After that, I plotted loss function values, and the reason why this loss curve is so noisy and lousy function values are fluctuate so high between batches is because of, for instance, of nature of multiple negative ranking loss function, where composition of the batch and thus negatives changes every step, and the loss value can fluctuate a lot between these batches. And because also this loss for 32 doesn't show much of loss. I also trained it on the higher loss and the higher batch size. It showed much higher and much more clearer loss of much clearer loss curve. Also, this one is for 128. And that after that, I finish the part 2 and part 3. I will continue with bonus point number 1, evaluating with function names. I used Python's regular expression module. I just used the function names from this CoSQL dataset. This is for just Python functions, not for any other programming language. And I use this. I indexed all these names. I evaluated it, and it showed much lower evaluation matrices, because I think because names have don't have that much of information, semantic information, and don't contain that much information like whole function body, and that's because it's much over evaluation. So bonus points number 2, changing storage hyperparameters. I will return to this file and to explain. So at the start, usesearch uses approximate nearest neighbor ANN for vectors, and in usesearch builds a graph of vectors, and each hyperparameter, like connectivity, expansion, and expansion search, tells how graph should look. So, for example, connectivity defines the maximum number of neighbors for each node. In graph, extension add describes the number of neighbors explored when adding a new vector, and extension search the number of nodes in graph explored during query search. So that for this part I try different hyperparameters and run it all of them, and it didn't show very much of changes in evaluations. And then I before this I tried to untrain data, for example, and it also didn't show that much of changes. So that's it. Also, I will share my Colab notebook in GitHub repo. This video will also be shared, and that's pretty much it. Thank you for watching, and goodbye.